Welcome to another free training session by Tigera. Today we're going to be going over one of Calico Enterprise's superpowers, Calico Enterprise Multi-Cluster Management. My name is Jonathan Sabo. I'm a Senior Solutions Architect at Tigera. Feel free to connect on LinkedIn. Just hop over here to the next slide. So most of you are probably familiar with Project Calico. I'm assuming Tigera we are the creators and maintainers of Project Calico. Project Calico, it is a community of developers and operators that maintain and develop Project Calico, which is an open source networking and network security solution for containers, virtual machines, and host-based workloads. So we provide the network connectivity, network security for the majority of the Kubernetes clusters that are out there on the internet. It's an open source project. If you're interested in contributing to the project, feel free to send us a pull request on GitHub Project Calico, our repo. You can follow us on Twitter at Project Calico. We also have a Slack, slack.projectcalico.org. You should definitely join us on the Slack. You'll be with another 4,000 or so Slack members. A lot of people who are out there doing production Kubernetes, specifically with Project Calico. In addition to the Slack channel members, a lot of the contributors and some of the developers on our engineering team hang out inside of the Slack channels. So if you were just getting started and you need some help with installing Calico, or you have a specific question about a specific environment, maybe EKS, AKS, or something on-prem, you can join our Slack and then just ask, and either one of us on the team at Tigera or one of the community members probably will be able to help and answer your questions. It's also good after these sessions if you want to follow up with us on Slack as well. I'm on there just at Sabo. Calico Enterprise is by far the most widely used CNI across Kubernetes. We're installed on over 160,000 different known open source Kubernetes clusters, and well over 1 million nodes are powered by Calico every day at this point. Today, we are going to talk a little bit about multi-cluster management capabilities with Calico Enterprise. We're going to get into the multi-cluster management federation for Kubernetes. We're going to do a demo, so it's not going to just be all slides. We are going to go through the Azure AKS MCM Federation GitHub repo. I'll paste a link to this inside the chat in a minute, so it's easy to copy and paste when we get to that. What we're going to do is we're going to talk about multi-cluster management. So a lot of people, you start out with a single cluster, and then you need another. Maybe you start to create clusters to break out like your various development environments. Maybe you have one for dev, one for staging, one for prod. Maybe you have different clusters split across failure domains inside of a cloud. Like you've got one in AWS and US East 1, one in US West 1 or 2, and you're have a standalone cluster in different regions. Or maybe you're in Azure and you're in US or East US and West US 2, or North Europe and West Europe, which is what the scenario that we're going to be running through here today. But for whatever reason, you end up with more than one cluster. It's a really quick and easy way to segment workloads. It's definitely not the cheapest way to obtain or to achieve multi-tenancy, but it's probably where most people start out. So as you start to have more and more clusters, it becomes more difficult to be able to maintain the security across those clusters. And what Calico Enterprise Multi-Cluster Management does is it gives you this single pane of glass, the single management plane to scale the security across all of your clusters. So you can join all of your clusters that you've created to a single management UI and manage the network policy. You can observe the workloads inside of your cluster. You can see the allowed and denied flows. You can manage policy. You have the ability to manage all the security controls across all of your clusters from a single pane of glass. In addition to that, we also have some other multi-cluster management superpowers. One of which is federated endpoint identity, and that's what we're going to be focused on today. One of the other capabilities that builds on top of federated endpoint identity is the ability to federate services across clusters. You can think of this kind of like a service mesh without a service mesh. You have the ability to create a federated service and have it span multiple clusters, potentially across regions. And you can do that with just native Calico Enterprise constructs without the need for like a service mesh like Istio or something like that. And one of the benefits of that is just native routing. And so you don't have the overhead of a proxy, for example, other than kubeproxy itself. It's multi-cluster management. It's also centralized monitoring, alerting, authentication, and logging. When you create a Calico Enterprise cluster, the clusters come in 3 different flavors: standalone, which is everything all in one. You can also designate one cluster as your management cluster, where you would have your centralized monitoring, alerting, authentication, and logging. And then you can create other clusters that are just that only have the Calico Enterprise policy and enforcement and networking capabilities installed on them, and they log back to that management cluster. So it allows you to like centralize storage and kind of maintain the things like Calico Enterprise flow logs, audit logs, DNS logs in a central spot. So you can allocate storage for that, maintain like whatever retention period that you might require for your security criteria in a central spot, and then add multiple managed clusters. And I'm going to show you what that looks like in a little bit here. So let's talk a little bit about federation for Kubernetes. So there's a couple of different capabilities here. The first one, and this is what we're going to be focusing on today, as I mentioned, is federated endpoint identity. And what this does, it allows you to include remote cluster endpoints to be evaluated in local cluster policy calculation. So if you have a cluster in East US, another cluster in West US, and you have another one in North Europe, and then another one in West Europe, across these disparate regions in Azure, and there is communication between the clusters, you have a couple of different options as far as how do I control who can talk to who, and which workloads inside of my cluster can talk to the workloads inside of the other clusters. You could try and do it by IP address. You could say, hey, the clusters in the East US are in this network prefix, and then in the West US are in this network prefix. And you could manage things using IP addresses. But as you know, workloads inside of Kubernetes are ephemeral, and they are constantly changing IPs. So it becomes a bit of a management challenge to do that via IP. And one of the benefits of Kubernetes network policy and Calico network policy specifically is the ability to use labels, to be able to use native Kubernetes constructs like labels for the pods, for namespaces, for service accounts, and to be able to control which workloads can talk to which workloads based on the label taxonomy that you deploy to your clusters. And so what federated endpoint identity does is it extends that past a single cluster across multiple clusters. There's a concept of a local cluster and a remote cluster, and you can subscribe them to each other in a federation and extend that endpoint identity. And then you can create policy that will allow a cluster to just say, hey, this workload is allowed to talk to the following, the dev workloads are allowed to talk to each other across not just this cluster, but all of my clusters. So dev can talk to dev, stage can talk to staging, prod can talk to prod, and this holds true across multiple clusters, potentially deployed in different regions and different accounts. Maybe some are on-prem, some are in the cloud. Calico Enterprise is multi-cloud and hybrid cloud. So you get to all of the features that we're going to be talking about today will work across all of those environments. You can define your security controls once and then apply them across all of those environments. It really is a time saver and return on investment as far as time for people managing Kubernetes security. We also have the ability to do federated services, and I talked a little bit about this a second ago. It allows you to extend the standard Kubernetes service and endpoints functionality across clusters. So you can create a federated service, and the endpoints behind that service, Kubernetes services are implemented by kubeproxy. And what they do is they load balance to the pods behind them. And those pods show up as endpoints. If you do like kubectl get endpoints for a particular service, you'll see all the endpoints. If you use Calico Enterprise federated services, those endpoints behind a particular service can extend across clusters. So you could create a federated service whose backing pods could extend across various regions. Very similar to some of the use cases you might attempt to achieve using things like service mesh. Teams that we work with, they a lot of the times they start to pursue things like service mesh because they want to be able to have multi-site, multi-cluster, multi-infrastructure service failover. They want to be able to have that global traffic control. They want to have global observability. And you can achieve that with these two constructs here, federated endpoint identity and then federated services, which builds on top of that. And this is made possible via Calico Enterprise. Federated endpoint identity. Each cluster in the federation acts as both a local and a remote cluster. So the local clusters, what they do is they subscribe to the remote clusters and they retrieve the endpoint data via the Kubernetes API. And remote clusters, they allow local clusters to retrieve that endpoint data. So they authenticate back and forth in order to be able to know which endpoints are available on the local and the remote clusters. And once you've set this up, you have the ability to create example policies like we have just described here. You can deny inbound traffic from all pods in a remote cluster except for those within the same namespace, which is one of the use cases that we hear from customers quite often is, hey, I want to make sure that all my dev workloads can only talk to my other dev workloads, but I need to make sure that that holds true across all my clusters. How do I do that? Well, this is how you do that with Calico Enterprise Federated Endpoint Identity. We're going to be working on a slightly different use case here as part of the demo and the training session, but we'll get into that in just a moment. And then federated services. Federated services, they extends the standard Kubernetes service and endpoints functionality across clusters. This provides cross-cluster service discovery for your local cluster. It uses the pod IP for the service endpoints and remote clusters like we just had been talking about a moment ago. This is used in conjunction with federated endpoint identity. So the first step is to create a federation. You have federated endpoint identity, and then on top of that, you can create a federated service. It's optional if you have an alternative service discovery mechanism that can plug in as well. But we give you federated services, and this is all part of Calico Enterprise. And I'll show you in just a moment where this is in our docs if you want to try this out in your own clusters. Calico Enterprise is, we have a multi-cluster management, and what it allows you to do is to centralize control of your many clusters under a single pane of glass. It gives you a single user interface, a single place to manage and scale the security controls that you need to be able to maintain compliance for your clusters if you're doing stuff for real for production workloads. A lot of times teams will start out early on, it'll just be like dev and testing workloads, but as things start to move into staging and then beyond where you're actually taking like live traffic from customers, you start to coordinate with teams. The networking team, the security team gets involved, and a lot of the requirements that are true inside of or outside of Kubernetes in your data center, your cloud come into play. And you can use Calico Enterprise to meet those security requirements, to be able to segment workloads from one another. And with Calico Enterprise multi-cluster management, you can do that not just inside of a single cluster, you can do that across clusters. And we're going to get into that in just a moment. Just real quick, we have some upcoming events here in the near future. You all signed up for the event today. We've got on November 11th, 12th, 17th, 19th, December 3rd, and the 8th, some other free training events. Some of them are in the EU time zone. So if you happen to be waking up way earlier than I do, you can join at a reasonable hour. We've got securing Kubernetes in your cloud native journey, getting up and running with Calico on your Rancher Kubernetes cluster. Rancher is probably one of my favorite distributions, Rancher and OpenShift. Troubleshooting services on Kubernetes, getting up and running with Calico on AKS, getting up and running with Calico on your on-prem K8s cluster. I'm actually going to be giving that training session. And then egress access controls for Kubernetes in the EU time zone. So if you have to access things outside of your cluster, beyond firewalls, Calico Enterprise has some capabilities that makes that easy to do. So you have some enterprise controls outside of the cluster. We just recently released an introduction to Calico, or excuse me, Kubernetes networking ebook. We're going to email out these slides after the training session here today, so you'll be able to click on that link in the slide, and it'll take you right to the ebook. Definitely check that out. It's a really good source of information for Kubernetes networking. We are also starting to do a certified Calico certification. And right now we're accepting people who want to be pre-registered to kind of gauge the demand for this. So far, there's a lot of people that are interested in getting Calico certified. So definitely check that out. KubeCon North America is happening later on this month. We will be there. Please come stop by and say hi. We're going to be giving away some AirPods. The first time I read this, we're going to be giving away 5 AirPods to 100 first booth visitors. I think there'll be 5 AirPods total. So definitely check out the Kubernetes networking ebook. Definitely sign up for the Calico certification. It's going to be a really interesting training, and stop by and talk to us at the KubeCon. So everything that we're going to do here in just a moment is part of Calico Enterprise. We also have Calico open source, and you can download and try that for free today. If you go to tigera.io/trial, you can try out Calico Enterprise for free, and you can do that in a couple of different ways. You can do that by signing up in our sandbox environment where we host everything, and then we also have a second option where you can actually join your self-hosted cluster in your environment. Maybe this is on-prem in your data center, at home in your home lab, or in AWS in your AWS account, or in AKS, or excuse me, Azure, inside of your cloud accounts. And you can create a cluster there and then automatically have it upgraded and added to the Calico, the hosted Calico Enterprise management plane. And so definitely check that out. It allows you to explore all of the Calico Enterprise use cases, the things like policy auto creation, policy recommendation, policy preview and staging, all the troubleshooting tools, all of the egress access controls. When you sign up for the trial, they actually provision another cluster too that has some like baked in use case workflows for you, so you can walk through and kind of go through and in a guided tour test out some of the different use cases, in addition to trying them out on your own inside of your own cluster. What we're going to do here today, you would be able to try out and probably in AWS, I believe. All right, so let's get started today. We are going to be running through this demo scenario, and I'm going to paste this into the chat. If you have questions as we go through this, feel free to use the Q&A tool, the Zoom Q&A tool. I will keep an eye on that. I'll be also watching the chat. If you have questions as we go, feel free to just ask whatever you want. I'll stop from time to time and kind of check out and see if there's any questions that we need to answer as we go through. So let's get started. So we have some commands here, and I'm just going to go through here. Some of these I've already completed because they take a long time to be able to provision the AKS engine clusters. It can take like, I don't know, like 5 or 6 minutes per cluster or so, and I don't want to spend all of our time waiting for stuff to be provisioned. So I've done some of this stuff already, and we're going to go through this. But the first thing that you need to do is so we're going to be creating 4 different clusters in Azure. And what we're going to do is we're going to connect to, we're going to peer them all together in a mesh so that we have a routed connectivity between each one of the 4 clusters. We're going to be creating AKS engine clusters, and we're going to be using the Azure CNI with Calico Enterprise. So the Azure CNI is going to be provisioning and wiring up routable pod IP addresses on the Azure network for us, and we're going to be using Calico Enterprise for network security. This Calico Enterprise Federated Endpoint Identity, one of the things that you need to have, kind of the prerequisites, is routed connectivity between your pods. And there's a couple of different ways to achieve that. If you happen to be deploying on-prem and you're integrating with your network fabric, basically like peering, Calico Enterprise can peer to your top rack switches, and you can advertise your pod cider to your top of rack switches, and then your network knows about your pods and your services optionally. You've made your Kubernetes workloads first-class citizens on your IP network. Then you can create federations on-prem. Another really easy way to do it is to use something like the AWS CNI or the Azure CNI in AWS's cloud or Microsoft's cloud, because those CNIs allocate routed IP addresses for you. Today we're going to be working in Azure, and we've created a couple of different clusters in 4 different regions. One in East US, one in West US, one in North Europe, and one in West Europe. So we have 2 clusters inside of the United States, and then we have 2 clusters inside of the EU. And so after you create the resource groups, you can deploy VNets for each region. And I do this as kind of a 2-step process because you want to create the virtual network, and then you want to create the cluster, and you want it to use that virtual network. The reason for that is I want to have the VNet, the virtual net, or the VPC in AWS, or the network potentially on-prem. I want to make sure that they're not overlapping. I want to make sure that I have networks that are going to be able to route packets between each other. So you want to make sure that you have non-overlapping networks for your different Kubernetes clusters. And I guess let's take a look at one of these real quick. Let's look at one of these VNets. So you can see this is the East US VNet, and you can see that the prefix, the address prefix for this cluster is 10.0.0/16. And if we come back and we look at, say, the West US 2 VNet, you'll see that this is 10.1.0.0/16. So they're non-overlapping. And that's the case for all 4 of the clusters. And then, so after we provisioned our resource groups, and then we provisioned our VNets inside of the resource groups, we're going to create our clusters that make use of those VNets. And this is just a quick way to get up and running with AKS engine. The definitions for these clusters are also here in this repo that you can use. Let's take a look at one of these AKS engine definitions. You'll see here that we are using the Azure CNI, and we are going to use the VNet that we created in the previous step. So we are going to create this cluster, and we are going to make sure that our masters and our worker nodes, or our controller nodes and our worker nodes, are using those networks that we created. All right. So I've already done this for us. We've created the resource groups. We've created the VNets. We've created the clusters. And I've also gone through and I've created bidirectional peering between each region. And if you follow along, you'll see how you can point and click your way to creating a full mesh between all of the different VNets. And we'll just take a look at that real quick. So this is the 4 clusters that we're going to be working with today. We've got one in the East US, and you can see the locations over here. So we've got one resource group in the East US, one in North Europe, one in West Europe, one in West US too. If we look at East US, and I click on the VNet, and we come over here to the peerings, you'll see that the East US cluster is peered to the West US, to the North Europe, and to the West Europe cluster. And if I come over here to the North Europe cluster, and we look at its peerings, you'll see that it's peered to the other 3 clusters as well. And it's the same for all of the clusters. So they are all peered in a full mesh. And what we end up with is routed connectivity across the world from between the United States and Europe, the West US to East US, and North Europe and West Europe. So we have routed connectivity across Microsoft's backbone between these different regions and across these different clusters. All right, and then what we're going to do is we're going to deploy Calico Enterprise. I've also done this too. Deploying Calico Enterprise probably takes 10 minutes across each cluster. And then what we're going to do next is deploy Calico Enterprise Federation for Kubernetes. And this is where we're going to start. Before we get started, let me take a look and see if we have any questions. Is it required for pod IP to be routable outside of the cluster for multi-cluster to work? Or is non-overlapping overlay network ranges sufficient? Today, you need to have routed connectivity. It does not work with an overlay network today. There has been a few people I've seen recently on the Calico user Slack ask about potentially creating multi-cluster connectivity using overlays. The Calico Enterprise Federation for Kubernetes requires as a prerequisite to have routed connectivity between the clusters today. So you need to have either using the AWS CNI and AWS, and potentially peering all of your VPCs together, or using something like the transit gateway. Excuse me, yeah, the transit gateway, or the in Azure doing federation, or excuse me, peering all of the VNets together like we've done here. Or if you happen to be on-prem and you've got data centers, you need to be able to connect them via connectivity using whatever network capabilities you have for your on-prem data centers. Maybe you've got like cages in Equinix or something, and you can the facilities enable you to have connectivity across the regions that they support, things like that. Or you have like dark fiber ran across your network. All right, so let's take a look at where we are here first. So we've got 4 different clusters. To kind of show what we're working with here. Cluster info. All right, so the top left is in the East US, bottom left is in the West US, top right is in North Europe, bottom right is in West Europe, okay? And if we take a look and we see Tigera status, this is how get Tigera status. You can see we've got Calico Enterprise, the operator install has completed and everything is up and running. All right. And so let's come back over here to the steps that we want to do. All right. So the first part of creating the federation across these clusters for Kubernetes, we need to create these kubeconfig files that are going to allow the service accounts to be able to authenticate with each other across these different clusters. So the clusters need to be able to authenticate across each other. And if you come here to our docs, And these are we just came out with Calico Enterprise 3.4 recently. You might notice a little bit the change in the structure of our docs. If you come to multi-cluster management, all the federated endpoint identity and services information is right here. And so if we click on federated endpoint identity, come down here, these are some of the steps that we're going to be going through. I've kind of distilled them down to be able to make it really easy for us to do in the short amount of time that we have together. But you'll see here, it's got like the federation RBAC and also the service account. Come back over here, you'll see it's the same thing here. And what we're going to do is we're going to deploy these to all 4 of our clusters. So let's go ahead and do that. Come back over here. All right, so we're just going to roll through the East US, the West US to North Europe and West Europe. And we have deployed the RBAC and the service account. All right, come back over here. The next thing that we need to do is we need to create the remote cluster kubeconfigs that we're going to use. So we've created the RBAC, we've created the service account, but now we need to get the creds and be able to create the kubeconfigs based on those so we can use those. There's a script inside of this repo that if you take a look at, you'll see that will make this really easy to do. So we're just going to go ahead and run that. And you can see we're creating the kubeconfigs, and then I'm testing, I'm using the kubeconfig that I'm creating to see, hey, is this actually going to let me authenticate to this particular cluster? And you can see that it's getting the service inside of the default namespace. And you can see that cluster by cluster by cluster, it's working out here for us. And let me see here. You can see we've created a couple of different files here. We've created the kubeconfigs. And that's what we've just done here in these last 2 steps. All right, so now we need to configure access to the remote clusters. And we're gonna do that cluster by cluster. So we're gonna start off with the East cluster. And what we're gonna do is we're gonna say, hey, we wanna talk to the East US cluster. And what we're going to do is we're going to add the remote clusters for the West US, North Europe, and West Europe. And then we're going to also add the remote cluster configurations for those. And the remote cluster configurations, these are documented down here. If you come down here, you'll see the steps that you need to take to be able to create the remote cluster configurations here. It's a pretty simple YAML file. It just kind of lines things up so we can do this very quickly. So let's start off with the East US cluster. Back over here. All right. And so now that we've done the East US cluster, so now the East US cluster is subscribed to the endpoints for the West US cluster, the North Europe cluster, and the West Europe cluster. Let me come back over here real quick. So let's do this. All right. Let me show you. So Calico query, what it allows us to do is query the endpoints for a particular cluster. And what I'm doing is I'm pointing it at a configuration that says, hey, talk to the West US2 cluster. And I'm evaluating all. And this function, what it's going to do is show me all of the endpoints on this cluster. So you can see right now, these are the pods. So an endpoint in Kubernetes is basically a pod. And you can see that the workload endpoint right now for this particular AKS cluster, they're all local to the West US2 cluster. If we look at the East US cluster, you'll see that we've got workloads endpoints that are local to the cluster, but we also have the remote endpoints. You can see that when we query the Calico East US cluster, we can see not just its own endpoints, but we can also see the endpoints that that it has subscribed from the remote clusters that it has subscribed to in the West Europe cluster, the North Europe cluster, and also the West US2 cluster. So if we look at the West US2 cluster, you'll see the number of endpoints here, and as we add, we work through the steps here. You'll see that each cluster will become aware of the endpoints that are available across all the other remote clusters. So let's just knock this out really quickly. All right. Let's take a look. So we just saw these were the endpoints that were all the endpoints known to the West US2 cluster. But if we ask again, now you'll see that the West US2 cluster not only knows about its own endpoints, but it also knows about the East US, West Europe, and North Europe as well. And so when we create policy, we can use the remote cluster endpoint information to calculate whether or not we're going to allow or deny inbound access to this particular cluster. And this is the kind of the behind the scenes, the low level details of how do we create policy across multiple clusters. All right, let's finish this up. So let's get through the North Europe cluster. Oops, boom. All right, and then let's go to West Europe. All right, that's all the clusters. So now, every one of the clusters, all 4 of our clusters, East US, is subscribed to and is in a federation with the West US, the North Europe, and the West Europe cluster. And the same is true in the other direction. The West Europe cluster is subscribed to the North Europe cluster, the West US2 cluster, and the East US cluster. So we have like a full mesh federation, and we have a full mesh connectivity across the Microsoft backplane via routed connectivity using the Azure CNI with Calico Enterprise, observability, and network policy enforcement and network security enforcement. So now what we're going to do is we're going to deploy our demo use cases to each region. It's really simple. If you look inside of the repo, you'll see just a really simple Ubuntu pod that's going to get launched inside of the default namespace. And it has some labels applied to them that will identify the geographic location that each pod is in. And we're going to use that to be able to create policy that will help us create some security controls here in just a moment. So first of all, let's just go ahead and deploy the demo use case. Come over here. All right, so we're going to create a Ubuntu pod in the default namespace in each cluster. All right, and then what we want to do is let's take a look at each one of the pods in each one of these clusters. So let's see here. My eye turned to magic. So if we look here top left, you can see that the Ubuntu pod has 10.0.0.41, and you can see that this particular pod is app equals Ubuntu, geography US, location Virginia, region US East, release stage dev. If we come down here to the one below it, you can see that it has 10.1.0.78. It's app Ubuntu, geography US, location Washington, region US2, release stage prod. If we look at the top right, we can see that this one is also app Ubuntu, geography EU, location Ireland, region North Europe, release stage prod, and then the one below it, app equals Ubuntu, geography EU, location Netherlands, region West Europe, release stage dev. All right, so now we know that we have 4 clusters in 4 different regions, and we've deployed a workload into these different clusters, and they've got a label taxonomy that allows us to differentiate them via region and via location. Let's log into each one of these. All right. So now we're in the pods, and let's install ping. And this is going to allow us to test connectivity back and forth between these different pods. I'm probably going to let's hop out of here really quickly and then just get the IP addresses once more. And so let's test before we apply any network policy. Let's see, can all of these clusters and all of these Ubuntu pods ping the East US pod? And you can see we've got full connectivity. Every pod in the different clusters across the 4 different regions can all ping the East US. Let's try to ping the this one, the Ireland cluster, the one in North Europe. And you can see all 4 of the clusters can all ping the workload inside of Ireland. Let's test this one too. Let me see if I can find that IP address. All right. This is the West Europe cluster. It's in the Netherlands. And let's ping that pod. All right. So you can see all of the clusters have a workload running them in the default namespace, and they can all talk to each other. All right. So now what we're going to do, let's take a look at the label taxonomy applied. So what we're going to demonstrate today is a multi-cluster management use case that comes up from time to time when either the customer happens to be operating across the world, and they might have security requirements around GDPR, like data sovereignty requirements. Microsoft makes this really easy as far as the data at rest requirements. You can use Azure functionality to ensure that data at rest stays within a particular region. But for data in transit or connectivity across clusters, sometimes you need to have network policy in place to say, hey, all of the clusters inside of the EU for particular workloads that have to be GDPR compliant, they're not allowed to talk to the clusters inside of the US, or they're not allowed to send data to non-EU clusters. So that's the use case that we're going to pursue today. As we mentioned earlier, another one is that is along similar lines is all my dev clusters can only talk to dev, or all my dev workloads can only talk to dev workloads across clusters. All my prod workloads can only talk to prod workloads across clusters across the world, or accounts or clouds or what have you. But let's take a look at the tags here, or excuse me, the labels. So there's 4 different Ubuntu pods here, and you can see the labels that are applied. And so this is kind of how you want to be able to create a strategy around microsegmentation. This is one of the things that we work with customers on, is how do I create a label taxonomy that's going to allow me to achieve the security controls that I need to have for the workloads that I'm running inside of Kubernetes. You can see that we've got a label for the region, a label for the location, a label for the geography, and also the release stage. And you can see how they differ across the 4 clusters that we have. We've got one in the East United States, one in the West, so East Coast United States, West Coast United States, North Europe, and West Europe. All right. And what we're going to do now is we are going to create some network policies. And we're gonna deploy a network tier that's going to hold our network policy. And we'll talk a little bit more about tiers in just a moment. But what this network policy does, you can see an example of it here, is it's saying that I'm going to deny access, inbound access to any connectivity that doesn't come from the EU with a destination of the EU, and I'm not going to allow any outbound access to the source that happens to be in the EU if the destination is in the EU. Okay, so basically this is going to say the EU workloads can only talk to the EU workloads, and the US workloads can only talk to the US workloads. All right, so let's go ahead and deploy this use case, this policy, this tier. Come over here. All right, and in just a moment we'll take a look at the Calico Enterprise user interface and kind of walk through stuff. But the first thing I want to do is kind of show you how this works. So we saw a moment ago when we were connected into each one of the pod IPs, or excuse me, into each one of the Ubuntu pods, we could ping each pod could ping every other pod across the different regions. So now that we've deployed our policy that's going to segment the workloads by geography, let's see if what happens now. So I'm going to hop out of here again, and I'm going to get the IPs once more. All right. And so this is the United States East US cluster, or East US workload. Let's see who can ping the United States East US IP address. You'll see that only the clusters on the left-hand side can. Only the East US cluster, only the East US workload, only the West US workload. The Control-C. Let's see who can ping the EU workloads. Let's try this again. All right, and you'll see this time the clusters in the EU can ping each other, but the pods inside of the clusters that happen to be in the United States cannot. All right, and so what this is an example of how you can enforce security criteria, things like GDPR or other multi-cluster segmentation scenarios that you might dream up. One of the two of the big ones that comes up from the customers that I work with often are GDPR compliance, being able to ensure data sovereignty requirements are being fulfilled, and things like the release stage, making sure that, hey, our dev workloads, we want to make sure that they can talk to each other across all of the regions, across all of the accounts, but we want to make sure that the dev stuff can't talk to the prod stuff, and vice versa. And so this is one of the ways that you can achieve that. So let's take a look at Calico Enterprise. This is the Calico Enterprise user interface. You can see here that we've added the 4 clusters. Right now we're looking at the management cluster. And so there's 5 clusters at play here. One is the management cluster that happens to be in AWS. And you can see that the notes here have like the AWS host name going on. If we look at the endpoints, these are all of the pods that are running inside of this cluster. And you'll notice that the IP addresses are 10.40/16. If we go from the East Coast, so 10.0.0.0, and we look at, say, the West Coast, and 10.1.0.0.0. So just as we saw before, and you can see 10.2.0/16. And then the same for West Europe. So you can see how you can very quickly and easily observe all the workloads across all of your clusters. And you can also manage the network policy for these clusters as well via the UI. What we did is we deployed a compliance control tier to each one of the clusters, and we have an enforced GDPR data sovereignty policy. And you can see that this is a global network policy. It applies to all the endpoints in the cluster. And if we look at it, we'll see here that the same policy that we showed you a moment ago in the GitHub repo is actually shown here. And so what Calico Enterprise does, it gives you a user interface to be able to manage network policy. You can manage things. You can come into the UI and create policy and then download it and then manage it as code, which is one of the things a lot of teams will do. Like they want to be able to very quickly and easily create the policies, but then they want to manage it via like a GitOps workflow or something. So I'm not suggesting that you have to do things via the UI, but we give you one. And you can see that this tier is before the default tier. Tiers are cool because you can create like a hierarchy of policy enforcement. So the developers that might be deploying stuff in the default tier, they're not going to be able to override stuff in the compliance controls tier or the platform tier, and the tiers are protected by RBAC. A moment ago, we saw that we're initiating traffic across clusters, and one of the other major benefits of Calico Enterprise is the visibility and troubleshooting use cases that we enable via things like our flow logs. So this is the Kibana dashboard. This is located inside of the management cluster. So all of these clusters that are deployed in Azure are all logging back to the management cluster, and I'm viewing all of the flow logs here, and you can see that we're looking for the flow action deny, and we're also filtering by the source namespace. And if we open up the flow log, you'll see this is a flow in the West Europe cluster, and you can see that this particular flow is being denied. You can see the destination is actually in the United States, geography US. You can see the IP address is 10.0.0. That's the IP address for our US cluster, and the workloads in it. And then you can see that the source is actually from the geography EU. And you can also see the evaluation of the policies across the tiers down to our data sovereignty policy. And you can see ultimately it's being denied. So typical flow logs you might be used to in like AWS VPC flow logs, or I don't know, flow logs in general, they typically give you the 5-tuple set of information: source IP, destination IP, source port, protocol number. But in Kubernetes, the workloads are ephemeral, and as they die or they're being deployed again, or Kubernetes is orchestrating them from node to node to node based on available CPU, based on available memory, the IP addresses are going to change. And depending upon how often you're releasing, how many nodes you have, that churn can be I don't know, it could happen quite often. And so if I wanted to report on the compliance of my security policies, and all I had is the information that shows me the IP addresses, but my workload could be on any of the IP addresses without knowing the workload identity, basically the label taxonomy, the Kubernetes metadata, that Calico Enterprise infuses into the flow logs, you're not going to really be able to prove that you were in compliance with your policies. So that's one of the main things that you get from like a visibility and troubleshooting and compliance perspective with Calico Enterprise. So that's pretty much all I wanted to show today with this particular training session. And I want to encourage you all to go to our website, tigera.io, and then come over here to the Calico Enterprise trial. And you can choose to either sign up for our trial and use our sandbox environment, where we can walk you through some of the use cases that we talked about today, or you can actually join your cluster that you have hosted in your environment, assuming it's one of the supported cluster types. It looks like today we've got kubeadm pretty much anywhere that you could run it, your laptop even, a Rancher cluster, or EKS, which is one of the places where you can actually do the use case that you saw today, the multi-cluster management. Because in AWS, the AWS CNI will give you routable IP addresses, and I actually have a link in the slides that we'll email you later that will point you to another example of this that we went through today, except it's in AWS. So let me just come back over here. Sign up for the trial. Definitely download the ebook. Register for the certification. I want to be Calico certified. And then come see us at KubeCon North America. We're going to be there November 17th through the 20th. I just want to thank everybody for your time. Thank you for joining us. Sign up for the rest of the other trainings if you found this useful. Hopefully this was worthwhile. Thanks.